Today we're going to be looking at two new words or concepts, but they use all the same maths that we've been using before. All we need to understand today is what these two words mean: angle of elevation and angle of depression. Now this is just a fancy way of saying looking upwards. So these examples, you do want to get this copied down. Think of this as like, this is your eye level here. The angle of elevation would be you looking up at something. So if I said to you, look at the top of that building, you'd need to look up at an angle of elevation. I've done the same thing, just made it face both ways. If a taller person walks into the room and you want to make eye contact with them, you need to look up at an angle of elevation so that you can see into their eyes. That's all this term means. This one here is the opposite. Angle of depression means looking downwards. So if you were standing at the top of that building and you wanted to look at a car on the road, you would be looking down at an angle of depression, to look down at whatever's lower than you. If a shorter person walks in the room, a little kid walks in the room and you want to say hello, you'd have to look down at an angle of depression, like the little arrow suggests here, to make eye contact with them. That is all these two terms mean. So have that down as your little reference point in your book, and I'll wipe it and put a little diagram up that I want you to copy as well. I've drawn a giant Z here. Now you may have noticed, like the pictures before, we're still working with triangles. So this is two triangles that I haven't quite completed, I haven't quite stuck together. What I want you to try and do before me now is put a little theta, that little symbol, where the angle of elevation would be in this diagram. So somewhere in one of these corners somewhere, I want you to put a little theta and then label it saying that that is the angle of elevation. Remember, imagine it's someone's eye level and they'd be looking up. Put a little theta where that would be, and underneath, write down angle of elevation to make sure you remember what it means. Do the same, please, for the angle of depression. Put another theta, the same symbol, put another theta where you believe the angle of depression would be. That is, someone that would be looking downwards. Where would that be on this diagram? Do that now, label them both, pause it, and then see if you've done what I did. Here they are. If you put the angle of elevation down there, that's correct, and the angle of depression up there. So see, again, pretend this is your eyes here. You looking upwards makes it an elevation. If that were your eyes there, you looking downwards makes that an angle of depression up there. I'm going to add two more bits of info to your diagram that I want you to copy down as well, please. The extra two bits of information I want you to write down, while it won't sound very important or might not make a whole lot of sense yet, it will make more sense when we start doing the questions. What's important to know is, always notice that whenever you're doing your angle of elevation, you start at a horizontal line and you move upwards. With the angle of depression, you always start at a horizontal line and you start looking downwards. That's really, really important, especially when we need to try and draw our own diagrams to answer the questions. Make a really important note of this, that the angle of elevation and the angle of depression are always touching a horizontal line. So you start horizontal and come up, start horizontal and come down. It's never in here, over here or anything, okay? And it's important to know that they are always equal. For example, if I gave you a diagram and said the angle of elevation is 53 degrees, that also means the angle of depression in the same diagram would be 53 degrees. So in the one diagram, those two numbers are always the same. They are always equal. That's important to know a bit later as well. Remember these two things for our third example. We're going to do 3 questions. Remember these bits of red info for the third example. Okay? I'll wipe the board clean. We'll do our first example now. Okay, these questions are always in worded form, which is okay because we've had some practice at that. And then it's up to you to try and turn them into a diagram. So I'm going to start you off a little bit and then I want you to try and finish off the diagram. I'm going to start by saying, you are here and we'll call that point A. Remember, our final product will always be a triangle, but draw whatever the image is talking about, whatever the story is talking about, sorry. So don't just draw a triangle. If it's about a rocket ship, draw a rocket ship. If it's about a ladder, draw a ladder. In this example, you are standing at point A and you are looking up at a tree. So you are standing at point A and you are looking up at a tree. So put your tree somewhere here. I'm going to get you to try and fill in your diagram with the information that I give you now. From point A, the angle of elevation to the top of the tree is 48 degrees. From point A, the angle of elevation to the top of the tree is 48 degrees. Remember, it's always going to be a triangle, so make it into a triangle. See if you can put that 48 in the right spot. Then, point A is 9 meters away from the tree. I could give you a bit of a clue and say 9 meters away from the base of the tree. The last thing you need to do is find the height of the tree. Now, I'll give you a clue. You've got to put an X somewhere because we're finding a length or a distance. In this case, a height. Put an X somewhere on your diagram. Find the height of the tree. Okay, let's do it together, see if we've got the same thing. Make a triangle. I said that point A, the angle of elevation to the tree is 48 degrees. There is the angle of elevation inside there. From a horizontal line looking up to the top of the tree, so it must be in there. I then told you that the tree, or point A, is 9 meters away from the tree. And then I said, find the height of the tree. All right, press pause. Label the sides of your triangle with O, A, and H, and circle the ones that you want. Once you get to here, everything is the same as it was before. So the only new thing you've learnt today are those words angle of elevation and angle of depression. Drawing the diagrams from words, same as what you were doing last lesson. And now all of this is the same too. You've circled O and A. Decide whether to use sine, cos or tan and write out your equation. Your equation should look like this. Go back to our rules if we've forgotten what to do next. The x is on the top of the fraction. So we need to do a bit of rearranging to make the x all by itself. Go. Now we're here. That's ready to go in the calculator. Type it in. Now this is a little bit tricky. I want the answer to 2 decimal places. But when you type it in the answer, you'll realise that it's a bit harder to round up. Have a go. So it comes out in the calculator as a number that looks like this, 9.995, blah, blah, blah. So we want 2 decimal places, 99. Next numbers are 5, we need to round up. What's after 99? 100. It actually just ends up being 10 meters as your answer. All right, but if you could get to that there, very well done. Just practice your rounding if you're not sure. All right, I'll do another one. All right, here's some information. I want you to try and draw this information before me. There's a man and he's standing at the top of the cliff and he looks down and sees a shark in the water. I want you to try and draw that. It's going to be a triangle, remember? So try and draw a triangle version of that diagram. It doesn't matter what way your triangle faces. I'm going to make mine the same one as the one before, so the point will be down here. Doesn't matter. Make your diagram. A man standing at the top of a cliff looking down at a shark that he sees in the water. Okay, here's your man on the top of the cliff. There's your shark in the water. We do want to make a bit of a diagram or a triangle out of it. So you can fill in the gaps if you like to make a triangle. So it looks like that. With this chapter, I actually like you to draw that Z shape like we had before. So we don't quite have the Z shape. We have that, and then I like to just draw that dotted line because it can help with angle of elevation and angle of depression when it comes in. Here's the information to now label and fill in your triangle. The man is standing at the top of the cliff. The cliff is 170 meters high. Put that on your diagram. He sees a shark. The shark is 210 meters away from the base of the cliff. What is the angle of elevation from the shark to the man at the top of the cliff? So this time we don't want a distance, we're trying to find the angle of elevation. So instead of putting an X somewhere, because you're trying to find an angle, put a theta somewhere. Alright, the cliff is 170 metres tall, so it goes on that side there. Your numbers need to go on a side, not in a corner somewhere, your numbers have to go on a side. The shark is 210 metres away from the base of the cliff down there. And I asked you, what is the angle of elevation from the shark to look up at the man? So the shark has spotted the man up there. His angle of elevation, it's always going to be touching the horizontal line down the bottom there. Label label O, A and H, circle the ones that you want. That's labelled, that's circled. Now choose sine, cos or tan and write out your equation. Here's your equation, bit different to the last one. We don't have an X anywhere, we've got theta here. So check your notes, look at what you need to do when you're trying to find out theta, write what the next line will be. Here is your next line. Now it's up to the calculator, type it in. Let's have our answer to the nearest degree, no decimal places. 39 degrees when rounded to the nearest degree is your answer. Okay, last example. Alright, now you're in the forest. This man here, as I'm sure you can tell, is a park ranger and he's standing at the top of a lookout tower and he spots a bear in the forest. So I've started you off with the diagram. I want you to try and fill in the rest of it as you get given this information. A park ranger is at the top of a lookout tower. He looks down at an angle of depression of 31 degrees and sees a bear. Now be careful with this, I'm going to give you a clue here. Angle of depression has to be touching a horizontal line. Draw your imaginary Z if you like, imaginary Z to help you with your triangle. I'll say it again, he looks down at an angle of depression of 31 degrees and he sees a bear. The direct distance from him to the bear is 27 metres. So the direct distance from him to the bear, direct distance is 27 metres. How far is the bear from the base of the lookout tower? So decide whether to put an X or a theta somewhere. How far? You're finding a distance or a length. How far is the bear from the base of the lookout tower? Let's label. Fill in your triangle. Draw your imaginary Z to help you if you like. It does help for this question. Now, if you put the 31 degrees here, I said he's looking down at an angle of depression of 31. Now, that's incorrect. The 31, if it's in there, is not correct because, have a look, it is not touching a horizontal line. Whenever you hear angle of depression, it has to be touching a horizontal line. So it doesn't go there. That's not touching a horizontal line. The 31 degrees must go here. That's the angle that he looks down at. So the 31 goes there. Problem is, that's not even inside our triangle. That's useless. But look back at those instructions. I wrote them in red at the start. It said it has to be touching a horizontal line, and it said that the angle of depression is always the same or equal to the angle of elevation. So if there's a 31 there, that means the angle of elevation in your triangle will be 31 as well. Put a 31 at the angle of elevation and you'll have a correct answer. Angle of depression, angle of elevation. You can put a 31 there as well. It means the same thing. So that's quite tricky, but have this example on standby if you get caught out again. It happens a lot though when you have questions with angle of depression. And then I told you the direct distance from him to the bear is 27 metres. So we don't really need that 31 up there anymore. That's not really any good to us. The information we need is here and here now. So we can ignore that, we can pretend it's not there. And then I said to you, how far is the bear from the base of the lookout tower? And X needs to go there. So that's the information that we want. We don't really want that anymore. Pretend it's not there, label your diagram with the letters and circle. Here we are. Now decide whether to use sine, cos or tan and write out your equation. Your equation looks like this. The X is on the top again, so maybe we remember what to do from before. Get the X by itself, rearrange, move around. That's what the next step should look like. Type it in your calculator. Let's have the answer to 2 decimal places. 23.14 metres is your correct answer. You've gotten the habit last time. I hope you're still doing it now. Worded question, worded answer. The bear is 23.14 metres away from the lookout tower. Get in the habit of writing the sentence underneath to express your answer, to state your answer. Okay, you can now go through the questions that are in the book.